Hello everyone and welcome to this Nordic Partner Webinar today with grandcentrix. Today's webinar is about IoT device to cloud project development with NB-IoT and LTE-M. Together with me I have Philippe Boul and Fabian Kochem from grandcentrix. I'll let them introduce themselves.
Thanks, Robin. So Philippe Boul is my name. I'm heading our channel and partner sales team and activities within grandcentrix since end of last year. And to give you a little bit of background, so my academic background is in business. For the last 7.5 years, I've been working within Vodafone, focusing on business customers and always with a blend of partner management, consulting, marketing, and sales activities. And in my last role, I was working as IoT solution consultant. So in total, I'm working about 10 years in that field of digital projects and mostly also on IoT or machine to machine, we used to say some years ago. I'm not holding this webinar by myself, but will be supported by my colleagues. So Pascal Serve, he's business development engineer from my team, and later on he's guiding us through the Q&A session. Oliver Viris, he's heading our team of production and certification. Kuldeep Dhaka, he's a colleague from our embedded department. And last but not least, Fabian Kochem. Fabian, please go ahead.
Yeah, thank you. And thank you everyone for joining. My name is Fabian Kochem. I am the product manager for our cellular IoT activities. My background actually is engineering. I built a couple of highly scaled infrastructure in the past. Then I switched sides, led the business development team here at grandcentrix, and am now responsible for all of the solution components and products within the cellular IoT space.
Thank you. And I am Robin M. Saltnes. I'm a product marketing engineer here at Nordic Semiconductor. I'll be mostly working behind the scenes in today's webinar. But first, I'll go through some practicalities. The duration of this webinar is about 60 minutes, consisting of about 45 minutes of presentation and a 15-minute Q&A session. We encourage everyone to ask questions in the top right sidebar. These questions are anonymous. We encourage everyone to ask a lot of questions, but try to keep them relevant to the topic, please. We discourage people from asking questions in the chat on the bottom right sidebar, because these questions will not be anonymous, and we generally don't check that as well as with the questions in the questions box. If you have more questions that are not answers, you can go to DevZone for Nordic-related questions, devzone.nordicsemi.com, or you can ask grandcentrix your questions at hello@grandcentrix.net. A recording of this webinar will be available together with the presentation at webinars.nordicsemi.com within a few days of completion. Then I'll hand the word over back over to grandcentrix.
Thanks, Robin. Thanks again for this opportunity for holding that partner webinar with you. So jumping into the content, the agenda for today is after an introduction to grandcentrix and what are we actually standing for. We are going deeper into the topic of low power wide area cellular networks. And we would like to have a view also on the challenges regarding IoT end-to-end solutions. Afterwards, and it's not only about challenges, it's also about solutions. Fabian will go with us through the solutions and components we do have in place already. And at the end, we would like to share with you some practical examples and use cases, especially about low power wide area connected products of our customers and which kind of products that could be. And we do have the Q&A afterwards. So let's start with grandcentrix. Grandcentrix is 100% solution provider for the Internet of Things, and we are 100% subsidiary of Vodafone Germany. And so with the acquisition by Vodafone in January 2020, grandcentrix is now part of that IoT global market leader with regards to number of connected devices. So By the way, over 100 million connected devices so far. And as grandcentrix, we are bringing all the different professional service disciplines as well as solutions and components into that IoT game, which are necessary to fulfill successfully projects for our customers and for our partners. So what are we standing for? We connect your products simply, safely, smartly. And we strongly believe that, or to be in a better position when having strong partnerships in place. So thanks again towards Nordic for this webinar. And of course, we are proud to be the only Nordic partner right now listed in both categories, meaning we are design and solution partner for Nordic. And moreover, and I think worth mentioning, is that we are also a Microsoft Gold partner, and we will come back to that backend piece later on when Fabian will talk also about Azure, the Azure Hub in the solution part. So looking at the vision and the mission of our company, the vision is that everything that can be connected will be connected. And our mission is we want to make IoT affordable and available. So I guess the vision is pretty clear stated here. And of course, we all want to see that kind of market growth in IoT, but let me go with you to that mission and bring it into some more context. So with that mission, we are aiming to become, let's say, the Henry Ford of IoT. We haven't founded IoT, but we want to industrialize IoT. And we want to bring it to a broad market and a broad variety of products being connected in the Internet of Things. So why do we think like that? Because as one of the pioneers of large-scale IoT productions and projects delivered, for example, the Fiesmann heaters, Miele washing machines, or the Tony box being used by many children out there, we know how complex IoT projects are and can be, and which kind of big numbers and budgets are necessary to cover those in the past, at least, and which risks are in place. And we are talking about that in the part of challenges. So we simply want to support our customers and our partners to get rid of those barriers in IoT projects, reducing risks and reducing also the budgets needed. And how are we approaching this? This is based actually on two main aspects we are covering today. So first, component. A component strategy which has already taken place for the last years in our company, and also as a kind of result of the acquisition from Vodafone. So the result is that services which previously required project work can now be licensed as component, blueprint, or used as service, for example, as a platform as a service. And this makes IoT significantly more cost effective for the customer, for the partner, and also accessible to a broader market than before. And second, focusing on low power wide area cellular IoT networks, so in brackets, narrowband IoT and LTE-M, we strongly believe that this is setting the basis, so being able really to industrialize IoT finally. And this is why we are aiming to be a global leader in that space of connecting products and delivering embedded hardware, especially by connecting it by low power wide area networks. To give you some more figures after that background, so grandcentrix has about 200 experts, 150 engineers, 1/3 of them are in embedded and hardware, and about 2/3 are in software, so backend, front end, apps, and also data science. And we successfully delivered over 150 projects so far in the last 11 years. And it's worth mentioning that we shifted our positioning starting from an app company 11 years ago towards the support of our customers in IoT end-to-end projects, especially how can we support our customers in getting the physical thing into the Internet of Things in the most convenient way. So this leads us to our competencies, which are the competencies actually that are necessary and that we are bringing to the table into that IoT end-to-end game. So as said earlier, it's an exclusive field of grandcentrix, and we claim to be able to cover all necessary disciplines. A, to complement the development activities of our customers, or B, to take over the overall responsibility also in complex development and operation projects. So we are coming to that point of complexity later on. And I would like to mention here, how do we work? So we usually work with agile methods and provide product owners in each and every project right from the start. And in addition, we do have and provide Scrum Masters and or user experience experts. And the development team consists of experts from our competence centers, which are shown here on the slide. And important is that the interaction of those different competence centers and various technologies is crucial for successful IoT end-to-end projects. Thus, we all have those on board internally. So going through them quickly, starting with our sweet spot. So embedded devices for embedded hardware and firmware development, as well as approvals. Device connectivity, speaking about the provision of cellular connectivity and provisioning processes. Manufacturing and supply chain. So Oliver is joining the call, and this is about the production of networked products or connected products, and even though box products if necessary and wished. It's about the back end, so we call it systems and infrastructure for building up platforms or integrating the systems. And on the right side, in the middle part, we do see the competence center of human-computer interaction. So that's about our mobile apps, so iOS and Android. Data science for the construction of data lakes, etc., to eventually gathering right and relevant set of insights from the data. And the lower part of that slide is showing what is crucial and what is also a key ingredient. It's about quality and it's about security. And these are support areas which are not handled like, let's say, acceptance case at the end, but they are looking on those, and we are looking on those aspects right from the start of development projects. So coming now into the part of low power wide area cellular networks. So many producers of products are looking for the shortest way of communicating with the products. That's our big guess, or not guess, but belief, is the shortest way might not be the best way in the long run. So why do we think like that? So first, we have to differentiate in low power wide area between licensed and unlicensed spectrum being used. So when we are speaking here about the LPWA, it's about cellular IoT networks such as narrowband IoT and LTE-M. Unlicensed wireless solutions such as ISM bands do not provide a quality of service. So for example, Sigfox and LoRaWAN, and besides that, there comes also a very high TCO due to building, maintaining, and operating a network. And besides the quality of service in narrowband IoT and LTE-M, the global availability is a big advantage. So when you look onto other transmission protocols and mediums like Bluetooth that requires pairing processes with smartphones or gateways, and at the same time, fixed and Wi-Fi networks have complex registration, and that leads to reduced activation rates of those connected devices, and it reduces the availability. So let's go deeper into that. What are the advantages at a glance? So low power wide area gives us the possibility, due to the power saving operations with battery lives up to 10 years, We do see attractive costs, especially in the connectivity part. We do have a deep indoor coverage, which makes it possible to reach even the cellar and the basement by that mobile network. Fabian will speak about that zero-touch onboarding, or what is shown here, plug-and-play onboarding later on, and of course the security aspects. Going even deeper into that, so narrowband and LTE-M, the main differences here is that narrowband supports the higher penetration with a narrow bandwidth. Both are based, by the way, on LTE 4G technology, and therefore make use of the cellular networks being already in place. So the sites worldwide, but here that's exclusively for IoT devices. And with LTE-M, we do have a higher throughput for the data traffic and a lower latency, and it supports voice. So in comparison with LTE-M. So very briefly, again, some figures. The key message here is both are based on LTE 4G, and both are able to connect things mostly where it was not possible before. And of course, one important aspect is also the scalability. So in terms of numbers of connected devices which are supported of the network, by the network, even on a cell level. One step even further down into the facts. At the end, it's about the requirements, and it's about the region and country, which technology might be the best for your product or your application being in place. And the last one about low power wide area networks, just a coverage map. So the network is already there, it's rolled out, and the rollout is continued by many operators and in many countries and regions globally. So the coverage continues on a global level, and it sets the basis, as mentioned earlier, to really come up with the scalability and having that piece already there and in production to industrialize IoT. So speaking about the challenges, again, this is our sweet spot. So on the left, you see your product, your sensor. On the right, you see your IT landscape. And the key question is, how can we bring the physical thing into that Internet of Things, and how integrate it, or how to integrate it into the IT landscape. And how to do that, as said at the beginning, in a simply, safely, and smartly way. But it's not as easy as it might look like. So you are faced with a lot of challenges, and our customers, based on our experience, and also the customer projects done in the past, there are a lot of challenges, business related and also technology or technical related. Just running through that quickly. So business related, one of the key points is complexity. So complexity in managing all the pieces, different pieces in the puzzle, different working sections, deliverables, and in combination with a multi-vendor approach, and even further with indoor or in-house development, the risk of failure even increases. And there is another risk of failure due to just missing technical expertise. So really deep dive expertise in all those disciplines shown before. One other aspect is often the product misses the target market. So, and due to two different aspects. One, due to long development cycles. So it's simply too late, for example, and the go-to-market timing is pretty bad, just because of that long development cycles. So we are aiming to shorten that timing and to enable our customers to have a really shortened go-to-market time. And second, customer feedback is missing. So what is actually the product being used? How is it used? Who are the customers? And what we are experiencing right now is that our customers, they want to get that feedback directly from their, for example, friendly customers. They don't want to just have that prototype in place. They are going for direct customer feedback. But again, it's a big challenge. Of course, then the financial part. So there is a pressure on the return on investment, the ROI, the business case. And last but not least, business related, we are not a consulting firm regarding organization or transformation, but it's worth mentioning here that the right and relevant setting of the organization needs to be in place to really support those IoT products and services, because a lot of parts of the organization are then directly integrated into that. So different sales, and if you have different business models in place, the organization has to follow that, or vice versa. Coming to the lower part, the technical challenges, again, here it's about the integration, the harmonization. So we had on the business side the management of the pieces, and here it comes also to the integration of customer processes. So for example, the firmware encryption has to equal the backend encryption and topics like that. Speaking about the hardware, what we are often facing is that the customer is looking for something off the shelf, but it's simply not or nothing available. Then there is a low energy footprint, which is demand. It should be even self-sufficient. The construction space and size regarding the hardware is often a constraint or challenge, so to say. And also, for example, the antenna design. So all those aspects and challenges, that's the usual project stuff. Going further down about firmware. So when we are talking about low power wide area networks, and Fabian is going to that in a minute, we do have specific algorithms and protocols. So we do not have internet protocols. We do not have TCP/IP when using narrowband IoT. And for example, the implementation of the deep sleep mode. So how is it actually working? So what must be done? And differentiating on the network level or connectivity level, the non-cellular level, we already said, or I already said something about the lack of quality of service, maintenance and operations, and TCO, so total cost of ownership. And on a cellular IoT level, you have to know exactly what, for example, are the SIM states, what's about the roaming, directions of traffic, firmware over the air, how is it working, data volumes and tariffs, and we want to reduce all those barriers and reduce the complexity in there with our solutions. And backend, last points, you need to have, for example, unique device identification. You need to integrate that in your existing systems. You have to think about scalability. And last points, for example, the user interfaces and the benefit for users, also from a technical perspective. And you have to think about product life cycle. So for example, what's after 5 years? So what's happening when the product is sold, when it's repaired, when it's changed, handled, something. So all those challenges are typically those in end-to-end IoT solutions, and we experience based on our customer projects and also on the meetings we had. So coming to the solution part, so how is it solved? So the good news is that we already have all the components to connect your devices using low power wide area networks and using lightweight M2M. It's deployed, it's in production, and Fabian, please take over and guide us through what's that about.
Yes, I will. Thank you very much, Philip. as you rightfully outlined, there are a lot of challenges actually, but the good news is that we do have answers. So coming back to the big picture here, you have, again, your product, your sensor on the left side, and on the right side, you have your IT infrastructure. That could be your cloud backend, that could be an existing IoT platform, whatever you have in place. And the question really is, how do you get from left to right? And usually what we do, or what probably everyone else does, is to put, first of all, hardware like a modem from Nordic, for example, into the product, then use some cellular connectivity network, such as Vodafone's, and then have a piece of software where we have the cellular hub in place to take that data and transform it so it fits your IT infrastructure. And I want to guide you through all of these pieces, through all of these components briefly. And I want to begin with the hardware. So this is one example of what we got. This is what we call the nRF91 connectivity board. And it has this name because the centerpiece of this is, in fact, the nRF91, which supports both LTE-M and narrowband IoT. And it actually has a SIM card soldered on top of it. So what this piece does is, basically, it's very suited and suitable for quick projects, rapid prototyping, maybe even proof of concepts and field tests, so that you don't have to work with a rather large development kit, for example, but you can put this piece of PCB into your device and have it talking to the Internet of Things really quickly. On the left side, you see that there's a customer connector, which basically is very compatible with a lot of different interfaces. We also have the opportunity to extend the hardware interfaces, the peripherals here, using daughter boards. So if you have, for example, an RS485 interface, we have solutions for that in place as well. Next slide, please. Best thing about this is that it's already certified, at least CE. So if you are running commercial field tests, this is what you can use already. There's nothing to be modified. You must, however, bring some sort of custom firmware onto it. And for that, what we also have in place is an Edge SDK. So this basically guarantees compatibility with the rest of the system and shall increase the speed to go to production. And what really is important to understand here, that this is one flavor of what's possible. So this can also be seen as a blueprint, again, to get you up to speed. However, we fully expect that once you go beneath the field test, so if you want to do a large scale production or want to roll out, let's say, 10,000 of devices or even more, then you probably need to adjust or alter this piece. And for that, you have two options really with us. One is that you go back to our professional services and we help you to develop a hardware solution, which is then again based on assets like which I just explained, or just something that is really 100% custom made, tailored to your use cases. And the other one, since this is a Nordic webinar, I expect that some of you are already in that field of designing PCBs like that, maybe even use the NRF, and then that means for having to, or if you need to work with us, basically once you use the industry standard lightweight M2M on the device, on the firmware, you are compatible with the rest of the system and can make use of the rest of the solutions which we have. So this is basically what we think the best approach to a very complex field that we can think of. And it gets even a bit better because we as grandcentrix or Vodafone, we don't own your devices. They are still compatible with other solutions such as device management, for example, as long as they are also using or leveraging lightweight M2M. So next topic would be the cellular network. And yes, you just saw the map from Philip, what is available worldwide, but we are in the Vodafone context here, and what we can offer is connectivity in 30 countries, including the USA, including China, including Russia, all of these places, most of Europe actually. And this is what works out of the box. So you don't have to go to an MVNO or basically have to negotiate with a carrier of your choice which countries are included. This is everything done already by us, and it just is there for you to leverage. Next one. The more valuable part than just the cellular connectivity is our platform as a service, which we call Cellular Hub. So I mentioned Lightweight M2M before. Cellular Hub basically acts as a Lightweight M2M server, takes the data, it communicates with your device, takes the data which you send and transforms it into something that your backend understands. So for this, we have two adapters. I will come to them, but it is more than just that. So again, I mentioned the complexity of having to work with carriers, and we already have, for example, a redundant IPsec tunnel towards the Vodafone backbone, so that we can make sure that all of the data arrives securely in a timely manner, and then all of the management that has to be done, for example, to activate SIM cards, for example, to synchronize SIM card IDs and make sure that these are aligned with the unique identifiers in your backend. You might already have databases with, for example, device IDs or user IDs even, and you have to integrate them. This is all done by the Cellular Hub. And of course, it also includes a couple of basic features which you would just assume at this point. For example, firmware over the air updates, this is possible. And what we also have in place is a very flexible billing solution. So basically what it does is that you can pay once the device or the SIM card has been activated and not before, unlike other competitors where they just send out the SIM card and you have to pay a flat price up front. We believe that this is a more fair model because you just start paying for using the service once you really use it or your customers use it. So Cellular Hub as platform as a service is something that we build on top of the connectivity, and you really have to understand it as part of the carrier infrastructure in a bit. And I just said that we have two adapters which we support. So one of them is Azure IoT Hub. If you have an Azure IoT or even Azure interface already, it's really, really simple to hook that up with a cellular connected product. And here again, Cellular Hub acts as a translator between your device and your Azure IoT Hub. So you might ask the question, why don't you just use the Azure Device SDK on the device, for example? And the reason for that is because the Azure SDK will not work on your device once you are in a rollout scenario. Narrowband IoT, for example, is based on UDP. And that is unlike what the rest of the internet uses, and also unlike what Azure IoT uses. So if you use a TCP-based SDK, for example, the Azure SDK, use it with narrowband IoT, you have to expect data loss and also increased traffic usage in the past once you are in a very crowded narrowband IoT field, for example. So this is something you really have to avoid. And Cellular Hub, again, translates between UDP using CoAP and Lightweight M2M and puts it into something that the rest of the internet understands. And in this case, it doesn't only send the data, it does way more than that. It really integrates deeply into the concepts which Azure IoT Hub offers. For example, the device trends with the reported properties. You can even change desired properties, and it propagates back to the device for use cases such as device remote configuration. And what's maybe a bit more common in the wild is that that people tend to use MQTT in IoT use cases, and even for that we have native support. Also, MQTT is based on TCP, and we can translate or we can publish messages directly in the message format which you expect, which your system desires, basically, and we have a templating system to make that happen. Talking about security, which is one of the key aspects for us to release a robust and scalable product into the market. We always have security in mind. In fact, we do security in all of our projects from the ground up, like from the very first time. And what you can see here is that we have 2 levels of security which we leverage. First of all, we have the communication channel between the COM module and the carrier network. And for that, we use in the first layer just the basic LTE encryption. So that is what you also use when you are using data using your smartphone or doing telephone calls. Between the Vodafone backbone and our cellular hub, we use a VPN. Again, that's a redundant IPsec tunnel. And from there, between cellular hub and your IT infrastructure, we enforce the usage of TLS. In fact, it's technically impossible to do something unencrypted just because we think it has to be there and there's no way around it. If that is not enough for you and you want to build another layer of security, we also offer the usage, and we recommend it actually, the usage of DTLS. That is a security layer on top of lightweight M2M that allows you to do not only encryption of traffic, but also to uniquely identify devices in a secure manner so that your backend exactly knows that the device, that the data you've just received is actually from the device it pretends to be. So this is our approach to security. And then you might wonder, what does that cost? We have in the blue dotted line here, we have the service which we call Narrowband Plus, which basically bundles connectivity, cellular connectivity, as I just described, bundles that with the usage of Cellular Hub, and we offer that as a package. And we ask for 1 cent per day per activated device, given a certain rollout scenario. And we believe that this is really the best way to enable connected products nowadays to talk LPWA and really make it as seamless as it gets. And this is basically what we have in place. To round this up, I want to submerge a bit from the technical details and quickly describe what is possible with that. Some of you already know that, I believe. However, you can remote monitor your devices. So if you have a sensor or a connected product and you want to find out what it's doing, is there any error code, this is for you. Also, the other way around. So if you, for example, are somewhere else and you want to remotely control or configure, for example, a AC in your home or whatever it is you're working on, this is also possible. Over-the-air updates, I've mentioned them. If you want to roll out new functionality, for example, in your connected product, we support that. And again, we understand ourselves as part of the carrier infrastructure. So of course, everything that we do must hold up to carrier grade scalability standards. Zero-touch onboarding is something quite interesting, something that you do not achieve with the traditional methods of connecting products such as Wi-Fi or Bluetooth. That basically means that you can offer your customers to unbox a product, power it up, and it just works without any further configuration. And you know, if you have a Wi-Fi connected product, you must connect it to your Wi-Fi, must enter the password or do whatever there is. And with cellular connected products, there is no need if you can support it processually wise. How do we achieve that? That is because we have the SIM card in place. It already comes with the product, so connectivity is built in really. And there's a certain SIM state, which is called active ready, which basically means that the first time the SIM card needs to connect to the network, it automatically switches to active live. And that's the time when costs are generated. So this is what we believe is a really great feature. And furthermore, we have solutions in place, processes to integrate with your manufacturing process, with your factory, in case you need to do end-of-line tests. You can even use the real network for that in case you need that. And we also have seen a couple of use cases with fulfillment and logistics centers. So if you need to know in the logistics center, for example, which package goes to which customer, we also have answers for that. Last but not least, I briefly mentioned it, the security part. Again, the main advantage of using technology such as DTLS is to not only encrypt traffic, but to also guarantee a secure identity so that devices cannot impersonate as being someone else. This really makes it hard for attackers, and the Nordic NRF 91 actually has great support for that. And all in all, I think you can understand now why we think this is so cool, and it solves so many of the challenges which Philip has outlined. And this is my part, and I think Philip wants to demonstrate or show how this works in real life use cases.
Thanks, Fabian. Yeah, let's go to the last part of our content on the agenda introduced at the beginning. So coming to practical examples and use cases. So here on that slide, you all know that marketing stuff, so to say, even as a marketee. So a couple of years ago, the typical cases, let's put it that way. So in metering, so gas metering and water metering, yes, they are there and they are in place. Also environmental monitoring, but maybe important to mention here is that what we see is also a combination of different protocols. So for example, combining low power wide area networks. So for example, narrowband IoT with wireless M-Bus or Modbus. We've seen that before in devices being in place. What's more exciting stuff is what are we actually doing, which kind of cool projects are delivered or in delivery and in progress. So for example, think about bets. So I think this is something nobody has seen that on those marketing slides a couple of years ago. So connecting products such as care beds, so for nursing homes or for hospitals. And we've successfully just launched or executed the MVP based on that narrowband IoT hardware and a cloud-based platform as well for digital bed and client management. So at the end of the day, to enable digital services, for example, one cool use case is the out-of-bed alarming. So be there when the patient drops out of bed and giving the help he or she needs. So looking on the upper right corner, it's also about, for example, power plug or distributors. So there are narrowband IoT modules in there. Again, here in combination with Modbus RS485. And the use case behind is, for example, to be able identifying the consumption of third parties when it comes to big production or industry sites. So this is also kind of legal wise, so legal norms in Germany at least. And the producer here wants to cover those aspects and coming up with those new business models or products covering those norms. The lower left corner is showing us something about connected lights. So we are developing the standard or serial product and also a demonstrator for a large manufacturer of lights. And here it's also about supporting also the protocols of building automation like KNX or DALI and also Zigbee. And having an interface, for example, to Saga. Again, the combination, what I mentioned earlier, we see that a lot. It's most often not just narrowband IoT. There are cases like asset tracking. Next one, so we are all also building products, serial products, for example, within the Vodafone Group. So right now, asset tracker, so the container tracker, which includes autonomous battery power and also supported by solar energy, to have at least 2 years or at maximum 2 years without battery charging. And second one is a robust tracker, for example, for construction assets. Then another nice industry case we are currently working on, that's about air compressors, connecting them. And again, it's a combination. Here it's Modbus to narrowband IoT. And there we are going even a step further into a real product and solution, having that hardware then in place in the product on the DIN rail. The case, the business side behind that is to enable after-sales services. So the challenge is, as mentioned earlier, not knowing the customer, not knowing the usage of the product, who is actually doing what with the product, how can we use that data and insights also for the development of further products. That's a nice case in that segment. And last but not least, in the lower corner, the connected air cleaner. We've talked about low power wide area networks and the advantage of deep indoor penetration. So going deeply into the cellar, the basement, and this is exactly the case here. So a narrowband IoT connected air cleaner, which is often in the basement, and remote monitoring is the main use case here. You see also some little pictures. Fabian mentioned it. It's not only the connectivity board as we have shown that. It's also when we come to serial products, different form factor maybe. But the connectivity board, again, that's a blueprint for us, for our customers, to start very quickly to reduce also the go-to-market time, as said earlier. And those examples are really the practical examples, the cool use cases we are seeing today. And it shows also the broad variety, as mentioned at the beginning. So, and this variety is even increasing. So maybe a last example, which is not shown here, it's about a sensor for roofs. So an area sensor where you're measuring if the roof or what's below the roof is really working, and if humidity and temperature are still in that category, or if they are above a threshold. And narrowband is the right technology here to connect those area sensors. And I guess, Robin, back to you for the closing.
Yes, thank you everyone from grandcentrix, and thank you everyone for watching this Nordic Partner Webinar. If you have more questions, don't hesitate to get in touch with grandcentrix, or if you have a Nordic related question, go to devzone.nordicsemi.com. And last but not least, sign up for more webinars at webinars.nordicsemi.com, or that other URL that it says there. Yeah, thanks everyone for watching, and have a nice evening.